All right, so I know that we're all here paying attention. Let's see. So you guys ready? So, class.
Yes.
Thank you. Again, the more that you pretend like you want to be here, the easier it is for me to pretend. So, let's go through and limits of functions, properties of limits. Now, if you have your calculator, calculators make this whole thing super duper easy, but we don't have to go that far. It's actually, most of these things are just going to be, can I plug it into the function? There we go. Basic limits. If f of f of x is equal to a is a constant, then for any real number, so if I'm seeing where it approaches c, it's going to be this. Here's an example. I'm taking the limit because I'm writing this in Mathanese, expecting you to. You ready? You see this now. This is what it means. So from Mathanese over to, whatever language we're currently speaking right now, okay, Ratchet, or, whatever Arizona accent we got. Can you plug in 3 into this function? Why? There's no x, right? There's no x. So my limit would be what? Just 5. That's what that means. There's nowhere to actually plug in the number. I get just that, right? That's what that means. All right. Yes. Yeah. You know, I just handed you 1.2. Oh, yeah. I'm sorry. I laid that fault this time. You know, it's like right in front of you, right? We need to get your classes checked. Okay. Seriously. All right. So find the limits of a sum, a difference, and a product. So this right here says that if I have a f and g are functions for which the limit of limit of f of x as x approaches c and limit of g of x as x approaches c both exist, then you combine them both into one type of limit problem, or you can go from one limit problem and break it up into 2 separate limits. This is going to be important, especially when we're talking about like weird ln things and we have to break it apart. So if we have ln of like x over y, I could break it up into ln of x minus ln of y. So stuff like that. So if I know what it is, I can break it up into different parts. That's not specific for this because this is an addition one. But still, we have to understand that each part has to have its own limit. All right, of a difference, same thing, but it's now going to be a subtraction. This one right here, this one is going to be a product. What does product mean? Anyone? Sum or multiplication, right? That's what that means. Multiplication. If you see multiplication happening in between there, then you can break it up into 2 separate limits. All right, who had 27? Okay. So this is going to be a product, so multiplication, I can break up those parts. This one right here. Like I said, a lot of these is just going to be, can I plug in the number? Can I plug in x into my function? Yeah. I don't have any restrictions. That's what we started off with. Because the definition of a limit is the left side and right side both have to go to the same number, right? Left side and right side both have to go to the same number. But if, notice, I don't have any domain restrictions. Domain restrictions would mean I cannot divide by 0. I cannot put negative numbers inside a radical. Those are the restrictions we've been talking about. But right here, I don't have any of it. Can I plug that in? Yeah. so it's going to be looking at 3 squared. So as you're writing this out and you're plugging something in, use parentheses, because that's going to be your biggest issue. I know a lot of people are going to screw this one up. That is the biggest issue on this, because a lot of people, if there is a minus sign in front, would I include the minus sign in squaring it? No, I don't. If there's a minus sign in front, I would not include it. But if there was a minus sign here, that would go inside. So location matters. So you have to be very careful with those things. So my limit is just going to be 9. All right, doing the next one. So like I said, when I plug in using parentheses. So, wait, homie needs one, right? Sorry, I just realized that. All right, let's see. So this says, as I plug it in, no restrictions. So it's going to be a -4 parentheses. So I'm plugging in -5. So that's going to give me a +20. A lot of people are going to make mistakes, especially if you're not carefully paying attention to signs. So, all right, right here, finding a limit. Can I plug in 1 into this thing? So yeah, I don't have any restrictions, right? No strange restrictions, so I can plug in 1. So that's going to give me 2 times 1. Oh wait, no, that's another parentheses. And then parentheses 1 plus 4. There you go. All right, so this is going to give me basically, it's going to give me a 2 times 5, which is 10. And I highly, highly recommend do not jump straight to the calculator on these things. Because when you start doing that, or if you're on your phone while I'm actually going over the lesson, you might actually have other issues. Uh-huh. Yeah. Hey! I probably do. I'm just kind of stupid right now.
Right now?
Yeah, I know, right? Anyway.
Your tests are great, they go.
Oh, you are awesome. Thank you. All right, same thing for the next one. Now, if there is no restrictions, plugging in 2 from the right side, is that going to make a difference? It's not going to make a difference because I don't have any restrictions. So I could just plug in 2 as is because it's not actually going to two separate sides. So again, 4 parentheses 2 minus there you go. All right, so inside right here we get 8 times 0, which is going to give me 0. Yay! Questions, concerns, complaints, conspiracy theories? No? No conspiracy theories? Good. All right, next one. Find the limit as x approaches 2 if it exists. Now, for the limit to exist, what has to happen? Both sides, left side and right side, go to the same number. So this right here is going from less than 2, and this is greater than or equal to 2. So this right here, this one is going to be my left side, and this is my right side. So let's plug in 2, see what we get there. So at 2, 3x plus 1 is going to give me 6, 7. No? Did I get it wrong? Are you sure? Oh my. Okay. Next one. Plug in the next one. So that's going to give me. Let's see. On the inside, that's going to give me 1 times 4, which is 4. So this is my limit as x approaches 2 from the left. This is the limit as x approaches 2 from the right. Are you speaking? Okay, say it again, please. Yes, limit as x approaches 2 from the left. The symbol with the little minus sign. Yes, that is a 7. Yeah, so if someone wasn't on their phone while we were actually talking about this the first time, yeah, I know. I'm trying. My pen is like blocking. So I don't know if that's the software or just my pen sticking. Okay. All right. Now, asking the question: does this limit exist? I got 2 yeses and 2, 3 head shakes. Why are you guys cuddling? You guys shouldn't be that close. Seriously, why are you guys so close to each other? That's weird. You gotta leave some space. Gotta leave some space. Dude can't use his other hand there. Oh yeah, there we go. Ah, see? All right. So, Blake, tell me. It's not approaching the same number. So this limit does not exist. Is that a little bit better for you? All right. Find limit of a tower and the limit of a roof. So, same thing. Same information here. So, this is key because you'll probably need this. So, if it's just a function in there, the function itself still has to be positive, right? Or equal to 0. No negative numbers. And over here, it means the same thing. All right, final limit of power rule. Is there any restrictions on this one? No restrictions, right? If there's no restrictions, I could just plug it in. So that's going to give me 2 to the 5th, which gives me 32. Is that a little bit better? For those people that want to sit way in the back. What about B? Is there any restrictions on B? Nope. Plug it in. So that is parentheses 2 times 1 minus 3 to the 3rd. So 2 times 1 is 2, minus 3 is negative 1. Negative 1 to the 3rd power is negative 1. Yes? Did I go too fast? Open. Are we taking notes still? Or just on the computer now? You're not the only one. I'm just... Still notes? Okay. I kind of hate it when I'm trying to do notes and like people are working on other people's classwork while I'm actually trying to do my stuff. But, you know, like other people's classes care more about their class than mine. But you ain't heard from me. I ain't going to gossip. What about this one right here? What would I do? What do I do with that? What am I replacing x with? I heard it? Yeah, c. As x approaches c, so I'm trying to replace x with c. So let's replace x with c. So that means that that's going to be c to the n. Does that make sense or is that nonsense? Are we still good? Hopefully. Ooh, this one might have some restrictions. Why would it might? Do I see a radical? Very good. There we go. So radical, you're like, oh crap, there might be a restriction, but you notice right there that's an odd root. So I'm allowed to have negatives with an odd root. So let's just plug it in there. So that's going to be, now I'm going to rewrite this because I hate writing radicals. I really do. And when we start doing more derivatives, it's going to make your life a whole lot easier. So I'm going to rewrite this as the limit as x approaches 4 of parentheses x squared plus 11 raised to the 1/3 power. You guys have seen this before, right? Okay, so yeah, this is going to be key because changing it up, it's going to make life a whole lot easier when it's time to actually start doing derivatives. All right, so let's go ahead and plug it in. So I'm plugging in 4. 4 squared is going to give me 16 plus 11, 27. So that's going to be the 3rd root. That means something to the 3rd power is 27. 3. So, and if you, like I said, if I rewrite it the other way, this should be 3 to the 3rd power equals 27, right? Okay. So we're going to use a lot of these right here, the roots. So knowing these by rote or off the top of your head is going to be very, very helpful. All right, where are we at? Next one, find the limit for these ones right here. So now fractional power, that goes with what I just did right there. Same thing, with an example. Now, this one right here, this is written in this form. In this form, the top number of my this is going to be super helpful if you did not know this already. So when I actually have something like that, D is the root, C is the power. So I'm hoping you guys have seen this and do understand this already. Yes, no, maybe? Okay, so that tells me, what do I tell me about my root? It's a square root, isn't it? Now, what do I know? Is the restriction with square root? Can't be negative. All right, there we go. So inside of this parentheses, I can't be negative. So let's go ahead and plug it in and see what we get. So what it's saying is 9. What is the square root of 9? You could do this in either order because power and root, if I'm talking about order of operation, it's like saying multiplication, division. They can happen at the same time, whichever comes first. But in this case right here, they're coming at the same time, so you can do either first. So I'm going to show you why that's going to be helpful. What is the square root of 9? And what is 3 to the third power? There we go. Or you could do the other way. What is 9 to the third power? Something big? Okay. Was it 280? 287? And then take the square root of that number. You'll get 27. But if you take the root first, it makes your life easier. Yeah, smaller numbers are actually better and easier. But it will work the other way. All right. Polynomials. Okay, just polynomial. So from polynomial, that means what do? Just plug it in, right? Okay. Most of the time, I don't have a restriction, so I can just plug it in as is. So that's going to give me 4, 3 squared minus 3 plus 2. All right, so 3 squared is 9. 9 times 4 is 36. 36 minus 3 is 33, plus 2 is 35. Is that what you guys all had? Hopefully. Same thing for the next one. So 7, -1 to the 5th, plus 4 to the 3rd, -1 to the 3rd, minus 2, and that is 1 to the square. All right, right here. So -1 to the 5th power is going to be -1. -1 times 7. Now, next one right here is going to be -1 to the 3rd power times 4. So that's -4. Now, right here, -1 squared, +1 times 2, or -2. There you go. And so I end up with a grand total of this is all pretty easy. Like pretty straightforward here, right? All right, division, same thing. They both have to exist in the bottom. My denominator cannot equal 0. And then we have average rate of change, which is just the slope formula. Now, I'm going to stop here today. I'm going to let you guys have time to work on your assignment. And then, how many more slides do we have? 4? Yeah. And we're going to finish this up tomorrow in class. So work on your assignment. Make sure you like, share, and subscribe.